Hello friends, I am your maths faculty from QLS Academy. So, we were studying the topic areas related to circles. Let us proceed and learn some more about this topic. So guys, you have already come across the terms sector and segment of a circle in your earlier classes. Recall that the portion or part of the circular region enclosed by two radii and the corresponding arc is called a sector of the circle, and the portion or part of the circular region enclosed between a chord and the corresponding arc is called a segment of the circle. Now, here we have a figure in which shaded region OAPB is a sector of the circle with center O. Angle AOB is called the angle of the sector. Note that in this figure, unshaded region OAQB is also a sector of the circle. For obvious reasons, OAPB is called the minor sector and OAQB is called the major sector. You can also see that angle of the major sector is 360 degree minus angle of AOB. Now, in our next figure, AB is a chord of the circle with center O. So, shaded region APB is a segment of the circle. Now, you can also note that unshaded region AQB is another segment of the circle formed by the chord AB. Again, for obvious reasons, APB is called the minor segment and AQB is called the major segment. Now, when we write segment and sector, we will mean the minor segment and the minor sector respectively, unless stated otherwise. Now, with this knowledge, let us try to find some relations or formulae to calculate their areas. Let OAPB be a sector of a circle with center O and radius R. You can see the given figure. Let the degree measure of angle AOB be theta. You know that area of a circle, in fact of a circular region or disk, is pi r square. In a way, we can consider this circular region to be a sector forming an angle of 360 degree, that is of degree measure 360 at the center O. Now, by applying the unitary method, we can arrive at the area of the sector OAPB as follows. When degree measure of the angle at the center is 360 degree, area of the sector is what? It is pi r square. So, when the degree measure of the angle at the center is 1, then area of the sector will be pi r square divided by 360. Thus, we obtain the following relation or formula for area of a sector of a circle. Area of the sector of angle theta is equal to theta by 360 into pi r square. Now, remember that theta is the angle subtended by the sector at the center of the circle. Also, r is the radius of the circle and theta is called the angle of the sector in degrees. Now, a natural question arises, can we find the length of the arc APB corresponding to this sector? So, the answer is yes. So, again, by applying the unitary method and taking the whole length of the circle of angle 360 degree as 2 pi r, हम लिख सकते हैं that अगर सेंटर पर 360 डिग्री का एंगल सबटेंड होने पर आर्क की लेंथ है 2 पाई r, which is nothing but the perimeter of circumference, which is nothing but the perimeter or circumference of the circle, तो सेंटर पर थीटा एंगल सबटेंड होने पर आर्क की लेंथ हमको मिलेगी theta by 360 into 2 pi r. So, we can obtain the required length of the arc APB as theta by 360 into 2 pi r. So, we can say that length of an arc of a sector of angle theta is equal to theta by 360 into 2 pi r. Now, let us take the case of the area of the segment APB of a circle with center O and radius r. You can see that area of the segment APB is equal to area of the sector OAPB minus area of triangle OAB, which is nothing but theta by 360 into pi r square minus area of triangle OAB. So friends, you need to remember that हमारे पास area of segment find करने का कोई direct formula नहीं है. हम दो formulae की help से area of segment find करते हैं और ये दो formulae हैं area of sector and area of triangle के. You can observe that area of the major sector OAQB is equal to pi r square minus area of the minor sector OAPB, and area of the major segment AQB is equal to pi r square minus area of the minor segment APB. Let us now take some examples to understand these concepts. We have our first problem in which we have to find the area of the sector of a circle with radius is equal to 4 centimeters and of angle 30 degree. Also we have to find the area of the corresponding major sector. We have to take pi is equal to 3.14. Now the given sector is OAPB. Now we know that area of the sector is equal to theta by 360 into pi r square. So we have theta by 360 into 3.14 into 4 into 4 centimeter square. So this can be written as 12.56 divided by 3 centimeter squares, that is nothing but 4.19 centimeter square. Now area of the corresponding major sector will be equal to pi r square minus area of sector OAPB, that is the smaller or the minor sector. So 3.14 into 16 minus 4.19 centimeter square is equal to 46.05 centimeter squares or 46.1 centimeter square approximately. Alternatively, area of the major sector can also be written as 360 minus theta divided by 360 degree into pi r square, because सेक्टर के एंगल का फॉर्मूला होता है थीटा बाई 360 इंटू पाई आर स्क्वायर. अब यहाँ हम थीटा की जगह रखेंगे 360 माइनस थीटा जो हमारे मेजर सेक्टर का एंगल है. सो 360 माइनस 30 डिवाइडेड बाई 360 इंटू 3.14 इंटू 16 एज थीटा इज नोन टू अस. सो 330 divided by 360 into 3.14 into 16 centimeter square, that is equal to 46.1 centimeter squares. Now our second problem says that find the area of the segment AYB, which is shown in the figure, if radius of the circle is 21 centimeter and angle AOB is equal to 120 degree. Here we have to use pi is equal to 22 by 7. So area of the segment AYB, as we learnt, area of segment is found using two other formulae which are of area of sector OAYB minus area of triangle OAB. इसे हम लिख लेंगे as equation 1. Now area of the sector OAYB is equal to 120 by 360 into 22 by 7 into 21 into 21 centimeter square, that is equal to 462 centimeter square. Now for finding the area of triangle OAB, draw OM perpendicular to AB. I repeat, draw OM perpendicular to AB as shown in the figure. Note that OA is equal to OB since they are both the radii. Therefore, by RHS congruence, triangle AMO is congruent to triangle BMO. So, M is the midpoint of AB and angle AOM is equal to angle BOM, that is equal to half into 120 degree, that is 60 degree. Now let OM is equal to x centimeter. So from triangle OMA, OM upon OA is equal to cos 60 or x by 21 equal to 1 by 2 as cos 60 की value होती है 1 by 2. So we get x is equal to 21 by 2. So OM is equal to 21 by 2 centimeters. Also AM upon OA is equal to sin 60, which is equal to root 3 by 2. So we get AM is equal to 21 root 3 by 2 centimeters. Therefore, AB is equal to 2 AM, that is 2 into 21 root 3 by 2 centimeters, that is equal to 21 root 3 centimeters. So area of triangle OAB is equal to half into AB into OM, which is equal to half into 21 root 3 into 21 by 2 centimeter square, which is equal to 441 root 3 upon 4 centimeter square. Therefore, area of the segment AYB can be written as 462 minus 441 root 3 by 4 centimeter square, which is equal to 21 by 4, 88 minus 21 root 3 centimeter square. So friends, this is it for this session. We solved some problems concerning area of sectors and segments. I hope you enjoyed learning. We shall continue our journey in the next session.